Today we will start another part that is actually on maths. Differentiation is one of the very interesting part, and we can do the differentiation with the help of the limit, and that is called as the first principle. By the use of the first principle, how to identify the differentiation, that is the main part I am telling now. Here if I am making dy dx, actually what does it mean? Actually dx is one operator which is basically operated upon y. Now this is the increment in the value of the y and this is the increment in the value of the x. Now when there is the first principle, we want to identify the value of this dy dx with respect to the first principle. What is that? With respect to first principle, that is limit h tends to 0 f of x plus h minus fx divided by h. What does it mean? It means if there is a graph like this, if you have the graph like this, and that is say x, this one y, which is basically said as function of x. That means this is the function of x which is basically represented by y, and that is the x. Always all the time remember, when we want to identify any kind of or make any kind of say graphical representation on x means that is the independent variable and y is the variable which is basically dependent on the independent variable, say here x, it might be t or something else. So now what happens if there is one say typical type of one kind of graph, whatever may be. Now for this fx, what happens if there is somewhere, say for this x, we are identifying the value say fx, says for a small interval of time we are getting say x plus h. That means what? This is the value h from this one to this one. This is the value h, or rather we can say this is also can be represented as dx. Now at x plus h, this function has a value f of x plus h. Now what happens if I draw a perpendicular from this upon this one? That means this is one normal. So what is the difference here? These two difference is f of x plus h and this one fx. So finally we can say this is f of x plus h minus fx. Basically in y direction there is little bit increment in the value. So we can say this is like dy. So what is the dy dx? Means dy this one fx plus h minus fx, and dx means that is h. So finally we can write dy means this one and dx means h. Why we are providing this limit h tends to 0? Because we are thinking about this part, this particular curvature we don't want to accumulate. Actually we want to say this particular part dy dx means this part is like one right angle triangle, this one dy or fx plus h minus fx, and this part is dx which is rather h. So if this one is a right angle triangle, then and then only we can say dy dx is like a, if this one theta, then dy dx is called as the gradient, or we can say tan of theta, like this. That is the main part. So now what happens here? We are getting this f of x plus h minus fx by h, but when this part is tends to 0, then the curvature is so small that it will be looked like a straight line, right? So that we have to say or take care of this limit h tends to 0. Tends to 0 means that should not be equal to 0 but very small in amount. If that is equals to 0, then what happens? This h, and if that is 0, then x becomes x only. So there should not be any kind of change. So that will not be practicable in the sense. So we have to make this kind of arrangement to identify the value of the dy dx. Now come to the part to identify the value of, say, dy dx. We want to identify for a very simple term, which is very simple. Say we are taking one part, y is equals to x. If I want to identify the value of this y is equals to x, and from that we want to identify dy dx, then what happens? Dy dx is equals to, by the use of the first principle, that should be equal to limit h tends to 0. Y means this is basically fx, that means f of x plus h minus fx and whole divided by h. That is the formula we have said earlier. So here what happens? If x means x, then what about fx plus h? Fx plus h should be x plus h, then fx is x again, so finally that becomes x. So finally what happens? And the lower term is h, so finally x and x crossed out, you will have limit h tends to 0, h divided by h, so these are crossed out and we will get 1. Here we must have to write as h tends to 0, therefore h must not be equal to 0. That is a very important term. That means when h tends to 0, that means this particular term should not be equal to 0, means the denominator, if that is equals to 0, then that becomes one kind of thing that should be called as the undefined term. So here this one should not be undefined, so we are taking h tends to 0 but h not equals to 0.